Hey everybody, it's Mr. Carr again. Today we're going to be talking about 12-2 day 2, and we're talking about what's called radians. So a radian is a unit of angle equal to an angle at the center of a circle whose arc is equal to in length to the radius. That's a little bit tricky on that one, but here's a question that might be a little bit easier to answer. What is the circumference of a circle with a radius of 1? So circumference is 2 times pi times r. So if I have a radius of 1, then that's just going to be 2 times pi. Okay, so a circumference of a circle with a radius of 1 is just 2 pi. That's a basic idea of what is representing our radian. Normally, a full circle is 360 degrees, right? If I have a radius of 1, another way of describing that is it is 2 pi radians. Okay, so again, 2 pi radians is a complete circle. So that's what we're describing with the radians. A full circle is 2 pi. Anything else is smaller portions of it. So it's just going to be dealing with fractions and related to that 2 pi idea. Okay, so first thing we'll talk about is how do we convert between degrees and degrees and radians? Okay, since we are dealing with two things that are describing a circle and describing angle measures, then we are looking at things that are related directly to each other. So we can either go from degrees to radians or radians to degrees. It's going to be the same idea, but reciprocal fractions. To convert degrees to radians, we're going to multiply by pi radians over 180. Reason why is if I look at, if I look at a complete circle, right, like that, it's going to be 2 pi radians for complete, or 360 degrees. So what that means is 2 pi is equal to 360 in terms of our two ideas here. But what if I take half the circle? Okay, let me do blue here. Half the circle is going to be 180 degrees. In terms of the circumference, it's half of the 2 pi. So if I take 2 pi divided by 2, that's just going to give me pi radians. So again, what that means is that 180 and pi are the same amount of the circle, I should say. Okay, so that's where we're getting this conversion rate from. Okay, so pi radians per 100 degrees. Or if I want to go from radians to degrees, we're going to do 180 divided by pi radians. To help kind of remember, whatever you want to cancel out, that's what goes on the bottom in the denominator. Again, so if we're starting with degrees, degrees is on the bottom. If we're starting with radians, radians go on the bottom. Okay, so that's our quick conversion factor. So let's use that a few times. So we want to rewrite 30 degrees in radians. So if I start with 30 degrees, we want to multiply that by pi radians over 180 degrees. Again, we started with this, like I could put it over 1. So that's going to be 30 degrees on top and degrees on bottom and make them cancel. Okay, so technically those will cancel. And I'll get 30 pi over 180. So let's reduce that fraction down. So I can take that, cancel out my zeros. I got 3 over 18. So I can divide by 3 for my numerator and denominator. So I get pi over 6 radians as my final answer. Pi over 6 radians. Okay. We write negative 5 pi over 3 in degrees. So negative 5 pi over 3. We're starting with radians. We're going to multiply this by 180 degrees over pi radians. So one thing to mention, you notice how I've got pi here and pi here, they already cancel each other out. Technically, radians and radians cancel out. So what this turns into is basically negative 5 over 3 times 180 degrees. That's it. So I do that. So negative 5 over 3 times 180, and I get negative 300 degrees. Okay, quick conversions. It's again referring to the same spots on that circle of where it is on the, so the idea is this. If I were to go to negative 300 degrees on the circle, that's the same position as negative 5 pi over 3 radians. Same idea is 30 degrees. 30 degrees is going to match up to pi over 6 radians. And that leads us to this idea here. This is something we'll come back to in the future, but it's the idea of what's called a unit circle. in all the spots on the circle, you can see what corresponds to what in terms of both degrees and radians. Potentially, it's helpful to remember this, but I think it's also, there's things to look for. For example, we know that 360 and 2 pi match up, pi and 180 match up because it's a half of a circle. If I take half of 180, that's my 90 degrees. So that's the same as taking half of pi, pi over 2. Okay. There's some tricks here that I'm not going to cover in this video, but a unit circle is going to be helpful for a lot of things that we do throughout the rest of this unit. So we'll come back to this in the future. For now, let's talk about one more idea today, and that is arc length. You would have covered this back in geometry, but now we also going to learn a slightly different adjustment to our formula. Okay. When you did this back in geometry, you would have focused on this idea. You can do the central angle divided by 360 multiplied by the circumference, 2 pi r. Okay. If we do that here, we want to do it in terms of radians. We're going to have a slightly different idea with this. Okay. The reason why is if we think about the idea of the central angle over 360, if we convert this, for example, if we have 2 pi and 360 there, 2 pi over 360 is one complete circle. That's kind of almost in terms of radians right there. So if I do that, if I take 2 pi divided by 360, then what I really get is this. Arc length S is the product of the r and theta as long as theta is in radians. Okay, so we just simply have to multiply the two things together. That's it. There is no, you don't have to worry about doing a central angle over 360. It's just radius times theta. But again, it has to be in radians. So either you convert first or they give it to you. So let's take a look at this one, for example. Find the length of arc AB. Okay, so given that 12 is my radius, just I guess units in this case, step one, we're going to first convert our central angle from degrees to radians. Again, unit circle might be helpful. 45 degrees is the same as pi over 4 radians. But worst case scenario, you can do the 45 over 1 multiplied by pi radians over 360. So you can just do it that way as well. Either way, you get to pi over 4. So now that I have my central angle in terms of radians, I can use my formula. The arc length is equal to the radius times theta. So in this case, it's 12 times pi over 4. So if I do that, that's going to give me 12 divided by 4 is 3. So it'll be 3 pi, not radians, whatever the units are in this case. It's tough to say. But if it was feet, it would be 3 pi feet. Okay. If it was inches, it'd be 3 pi inches for that arc length. So again, we're talking about the length going from A to B there. All right. And again, so it has to be in radians. Pretty easy multiplication between the two. Radius times theta. Okay. Steering wheel on a monster trunk has a radius of 11 inches. How far does a point on the steering wheel travel if the wheel makes 4/5 of a rotation? So first thing we want to do is we want to figure out the central angle. Well, if it's 4/5 of a rotation, that is 4/5 of a full circle, which is 2 pi. So we take 4/5 of 2 pi. Multiply that out, we get 8 pi over 5. That is our central angle. Okay, that is the angle that is 4/5 of a complete rotation. So now I have all I need to just plug it into my formula. Okay, so my radius is 11, and my theta is 8 pi over 5. That's my central angle. Okay, so I multiply those together. Can't reduce it as a fraction, so if I want, I can leave it as 88 pi over 5, and that'll be inches. Or I plug in my calculator and get an approximate number because I'm probably going to do that more versus having pi in the answer. So I'll come out to 55.29 inches. Again, this is how far it traveled all the way around. Like if I picked my hand here, it would have gone 55.29 inches in a circular path. Okay. And that is it for today. So again, we're talking about what are radians compared to degrees and using that to find the arc length of circles as long as everything's in terms of radians. Okay. So I have one more problem. You want to try that out on your own. You're doing 5/7, and the radius is 16 inches here. Okay. So that is it for today. Take care, everybody. We'll see you on the next one.